Today I'm going to be solving an example on this particular video series. Now this question here is a nail on a vertical wall is pulled by means of a cord attached to its head. If the cord makes an angle of 60 degrees to the horizontal and exert a force of 80 Newton on the nail, find the effective force which tends to pull the nail out of the wall. Then number 2, find the force which tends to bend the nail. Now we can represent it as I've drawn it here. It can be represented using this particular diagram. Let's assume that this is the what? This is the wall, right? Let's say this is the nail, right? On this what? On this vertical wall. This is vertical, right? Now, if the nail is like this, the rope we can, because it is not a rigid cord, so it has the ability to what? Bend down, right? They now said if the cord is makes an angle of what 60 degrees to the horizontal, so the horizontal of this particular cord could be this, or we could produce it here. So if this is 60 degree, we could also have 60 degree here, right? This is what angle of what alternate angle, right? So 60 degrees to the, and it exerts a force of 18 Newton on the nail. So what we are saying now is this cord, the force this cord exerts on this particular nail is what 80 Newton, right? So the question now says find the effective force which tends to pull the nail out of the wall. Now when we're talking about the force that will pull the nail out of the wall, we are actually talking about the the horizontal component, because the force that will pull this nail is when you bring it up here and you pull it out. So we are talking about this particular component. So in this case, this place can be written as f subscript x, right? Sorry, let me rewrite it. This is f subscript x. Don't forget that f subscript x is equal to what? F cos what? Theta. This is still on what? Positive x, because if we draw something like this here, okay, let me put it. If we draw something like this is positive y, negative y, positive x, right? So this is f cos theta is still on positive side, right? So in this case, how do we now achieve that? So if we want to look for the force that will do what, that will pull the nail out of the wall, so that will be f is equal to f of x is equal to f cos f subscript. So we can therefore see that f subscript x is equal to, what is the force? 80 times what? Cos what? 60. That would be 80 times, what is cos 60? Cos 60 is 0.5. 0.5. This is what 80 times 0.5, that is what? 40 Newton. So that is what the force that what tends to pull out the nail. Now if we want to look at the number 2, this is for number 1. So number 2, what will be the force that tends to bend the nail? So if we want to bend the nail, we can bend it like, we are going to bend it towards this direction. Now if you look at this, this is on negative what? Negative y. So it's gonna be what? F subscript y is equal to what? Minus f sine theta. So this will now be minus 80 times sine 60 is equal to what? Minus 80 times 0.8660, right? Now that will give us minus 80 times 0.8660. That will give us 69. My writing, that would be 69.28 Newton minus 69.28 Newton. Don't forget, we have to put the condition. So we can also write it as 69.28 Newton. And we put the reason. The negative implies that what? That it was bent, right? It was bent towards the south, that it was bent, right, towards negative what? Y what? Direction. So that is why I decided to put it here. But that negative implies that we bend it what down, right? So that is the problem. That's the solution to the problem. Subscribe to this channel for more videos and for more examples on vectors and physics and mathematics problems. Thanks for watching. See you.